Welcome to BBMPulsers. Today I'm gonna show you inside of this unit. So this is a 0.7 Tesla BBMPulser 2B3 model. I will post link down below this video where you can see the specs for this model, and I'll post comparing to Sota MP7, which is the latest one, side-by-side comparison, multiple parameters. Link to this file will be posted below this video. So inside, we're gonna take a look how it's built. Before I do that, I'd like to show you how it feels on my hand. So just give me a second. Okay, let's power it up. This is the high output, and it's got a power adjustment. You can kind of hear pulsation speed really fast. It does triggers muscle a little bit on the lowest, which is 0.3 Tesla. On about 0.5 Tesla, triggers muscles pretty good. You can see my hand twitching. That's how fast it pulsates. Okay, so let's take a look on the inside of the unit right away. Yep, it's got some power. Okay, took some screws off so we can take a peek inside of this unit. As you can see, it's fairly compact. There's barely any space here left. So let's go over components here. These are capacitor bank, consist out of 4 capacitors, and they are 1.3 kilovolt, 6.5 microfarad each, connected in parallel. There is 2 transformers, one here, and there's another one underneath this printed circuit board. This is a 12 volt low voltage power supply to feed the circuit and to run the circuit. There is 2 diodes, one there and one there. This is a part of, and that capacitor here, that's the part of voltage doubler. So first, this transformer's secondary is connected in series, steps up voltage to 480 volts, and then it feeds into the doubler, and doubler steps it up to close to 1300 volt, 1250. That's the max. There is a cooling fan here. There's 2 relays here on the top. One is for thermal protection. When coil gets hot, relay triggers and shuts off the recharging circuit. And the second one, relay, is for power on off. So there is a thyristor underneath there. You can kind of see the heatsink, the aluminum one, and underneath this relays there is a thyristor. Sits thyristor. On off button, pulse protection LED, power adjustment here, and safety label on the back, and with the fuse. There's a fuse underneath here. Well guys, this model is not open source, and that's because it's, as you can see, not easy to build. I am not trying to challenge anybody, because I know there's some of you even better than me and can build it better than I can, but overall, believe me, it's not easy to build this. It's just there's too many things in here that needs to be precisely fit into here in order for this to work properly and be a low profile like that. So as you can see my hand, this unit is fairly compact, but it's heavy. It's close to 12 pounds altogether. So I would like to make open source it, but for me to do that, before I do that, I do need to design one printed circuit board which will fit all of the components on it, similar to how I did for BBMPulser 5B board. You see, this board contains everything. There's a thyristor, power supply for low voltage circuit here. There's a doubler and 2 transformers. So I'd like to make one like this for this model, and then I'm gonna open source it. So, and it will be like this big. I'll try to compact everything on it. But for that, I don't have, it's not gonna be cheap, so for now I can't afford it. So if you guys wanted to see this open source, you gotta help me out. I do want to open source it because this model, I like everything about it. It's compact, it's portable, you can take it with you anywhere, you can set it up to go to work on 120 and 220 volts. It's strong, it works, it gives you like 10 minutes session time, thousands of pulses. Let me see here, pulses per session. So like 14,000 pulses on the lowest, which is 0.3 Tesla, and 2,000 pulses on highest, which is almost four pulses a second you get. So that's how much pulses you can get out of each session. It's got multiple protections, isolation from the transformers, which is safety protection, thermal protection on a coil. There is a thermal switch right here built in. It's grounded, it's fused, so everything should be good. Yeah, this board, when I was designing this, it wasn't cheap. For now, I'm still like trying to learn the software to design all this. I got other things going on, and like 3D printer software, learning to design the CAD and other softwares, and just life going on too. So a lot of things going on, and I wasn't able to learn KiCad. There's the open source software to design this printed circuit board. So for now, I am paying designers to do that work for me, and to get this one just like this on a board, it's probably gonna cost me like $1,000 at least $1,000. So as I said, I got other expenses going on, like trying to get the solar pulsar going, that or right now on a third revision. And yeah, anyway, okay guys, just wanted to show you this unit inside. Take a look on the bottom here. So if you can help me out with getting this started and I will open source this, and it will be easy to assemble just like this one on the board. So I will leave my contact information down below this video where you can get in hold of me and help me out on this. Thank you for subscribing. Thank you for liking my videos. Appreciate your support, and together we'll get it done.